Hey everyone, welcome back to the channel, and in today's video we're going to be dealing with sets and Venn diagrams, one of the most important topics in mathematics. Stay tuned to the end of the video so we'll unravel the mystery behind sets together, and I hope you enjoy every second of it. Alright, so let's get started. So what exactly is a set? A set is a collection of well-defined objects. Well-defined in the sense that one can easily tell what belongs to a group and what doesn't belong to that certain group. Now, I know all of these words seem huge and everything, but you will understand in a minute. So now, here are the notations or symbols that we would come across during sets. So this is the first one. This one means is an element of, while this means is not an element of, while this C signifies subset, while this one signifies union, this signifies intersection, this means complement, and N into A can means the cardinality of set A. Now, what do all of this mean? Now, let's get started. So, there are two ways of writing sets. The first method is the listing or roster method. While the second method is the set notation method. So there are two ways of writing sets: the listing or roster method and the set notation method. So what is the listing? What is the listing method? Now, this is an example of a set. For instance, example. Now, a set basically is a collection of well-defined objects, like I clearly stated. So now, take for instance, this is a school. This is a school. So now, the elements of this school are the students and the teachers that are inside the school. So the school itself is the set. So the elements are the things that are inside the set. So the element of, let's say, a school, a set of school now is the students, like, let's say student A, B, C, D. So these are the elements of this particular set. So now that we have that out of the way, so we have two ways of writing sets. The first one is the listing or roster method, and the second is the set notation method. So the listing or roster method is just you, let's say we have a set A to be equal to, so let's say set A to be equal to 1, 2, 3, 4, 5, 6. So this just involves you listing out the elements of that particular set. So listing them out like this is the listing or roster method. You just listing the set out like this clearly. While the second one is the set notation method. This one involves you actually defining the set. So like this. So let's say we have a set A to be equal to, let's say X. X is such that X is an even number less than 10. So this is the set notation method. While this is the listing method. So you can come across set questions in any form. Don't be starstruck or don't falter. So here is the first method, the listing method, so where it involves you just listing out the set. So, and this one is the set notation method, which involves you actually defining the set. So A is such that X is an even number less than 10. So that is how to write set. So set questions can come in any form. It can either be this or this. So let us proceed to another subtopic. We have various types of sets. So the very first one is the universal set. The universal set. it is denoted as mu. This is one of the denotations of the universal set. So what exactly is universal set? Now the universal set is otherwise known as the mother set. It's otherwise known as the mother set. This is the set that encompasses every other set. Every other set are gotten from the universal set. It's the set that houses every other set. Just like a mother gives birth to children, yes? So the mother is the origin of her children. So basically, the universal set is also called the mother set. It is a set that encompasses every other set. Every other set are gotten from the universal set. Now, that is that. It is denoted as this. This is called mu. M-E-W. So this symbol. So we also have subsets. Subsets. What are subsets? Subsets are sets that are gotten from another set. Now, for instance, let's say we have a set A to be equal to 1, 2, 3, 4, 5. And it now said B is a subset of A. Set B is such that it's like this. Set B is such that it's like this. 2, 4. As we can see here, the elements of B are 2 and 4, and they can be found inside of the set A. So set B was gotten from set A. So we can say B is a subset of A. So B was gotten from A. So that makes B a subset of A. So I can say my B is a subset of A. This denotes subset, like I stated here. So remember, the universal set is also called the mother set. It is a set in which every other set are gotten from the set that encompasses every other set. While subsets are sets that are gotten from another set. Like, for instance now, we have the topic. This topic is sets and Venn diagrams. And under sets and Venn diagrams, we have subtopics. They are not the main topic, but they are under the main topic. So if you understand in that sense, we'll continue. So now, so that is that. We also have union of sets. The normal definition for union in layman terms is union is when you combine two or more things together to form one thing. So yes, so let's say union of set refers to the combination of two or more sets. This is the combination of two or more sets to form a single set. So when you have a set, another set, and you combine them to form another set, you have unionized them. So that is the union of them is what you have. So example, let's say we have, now the union of set is denoted as this, U. It's kind of like a U. Not a U, but it's kind of like a U. So this is it. It's too big. Let me make it smaller. So here. This denotes union. So let's say we have example. It's an example like this. We have a set A to be equal to set A to be equal to 1, 2, 4, 6. And we have a set B to be equal to 3, 4, 5, 6, 7. And you're now asked to find A union B. Remember, this denotes union. So you're asked to find A union B. Now, A union B means combine set A and set B without repeating an element more than once. That is, if an element occurs, like for instance, if 2 occurs more than once in both sets, you have to write 2 just once without repeating an element more than once. So let us do that together. So A equals to this and B equals to this. You are asked to find A union B. So my set A is equal to 1, 2, 4, and 6 union set B is 3, 4, 5, 6, 7. So we have to combine these two sets to form another set, but without repeating an element more than once. So my A union B is now equal to, now the first element here is 1, so we have 1, we have 2, we don't have a 3 here, so write it in descending order. So 1, 2, so we have 3. So now, if you look closely, we have 4 in the first set. We also have 4 in the second set. So instead of writing 4 twice, you're going to write 4 just once. So you get the vibe. So the next thing to write is, okay, 5. The next thing to write is, we have 2 6s here, so just write 1 6. And we have just 1 7. So this is the union of both sets. You can see we did not repeat an element more than once. Any element that occurs more than once should be written just once. So here we had 2 here. Okay, we had 4 here. We also had 4 here. So instead of writing 4 4, just write 1 of the 4s. We also had 6 6. So instead of writing 2 6s, just write 1 of the 6s. That is how to find the union of sets. So without repeating an element more than once. So let us continue. So we also have the intersection of sets. So we also have the intersection of sets. Now this is denoted as N. So intersection of set means writing out the common element in each set. The element that is common to both sets should be written out inside of another set. So this is what I mean by that. So let's say I have a set A to be equal to 1, 2, 3, 4, 5. And I have a set B to be equal to a set B to be equal to even numbers less than 10. You can see the question we have here was written in 2 forms. This is the list method, while this is the set notation method. So now, we were asked to find A intersection B. Please, they should not be mistaken. Intersection is denoted as N, while union is denoted as U. So we're asked to find A intersection B. And intersection means finding the common element to each set. So now, our A is equal to 1, 2, 3, 4, 5. And my B is equal to even numbers that are less than 10. So the first even number less than 10 is 2. The next is 4. The next is 6. And the next is 8. We're told less than 10, so we're not going to write 10. So this is set A, while this is what? Set B. So my A intersection B is equal to, now intersection means the common elements to each set. So now, what do this set and this set have in common? They have 2 in common, so 2. And they also have 4 in common. So those are the only elements they have in common. So the intersection of A and B is 2, 4. So this is how to find the intersection of sets. So that is it. So now let's go to another one. That one is called the cardinality. Cardinality of a set. Now, what is the cardinality of a set? The cardinality of a set simply refers to the number of elements that are present in that set. So now, it is denoted in this sense. So let's say I want to find the cardinality of A. Okay, cardinality of A. So I will denote this as N into A. So N into A means the cardinality of A, or how many elements are inside of A. So for example, let's say I have a set A to be equal to odd numbers less than 10. I'm now asked to find N into A. And N into A means the cardinality of A. So first I have to write out my set A. And my set A is the set of odd numbers that are less than 10. So my set A is simply, the first odd number less than 10 is 1. The next is 3, 5, 7, and 9. So these are the odd numbers that are less than 10. So to find my N into A, I would simply count the number of elements that are present inside of set A. So how many elements are in set A? We have 1, 2, 3, 4, 5. So my N into A is 5. So my 5 is the cardinality of that set. And cardinality means how many elements are present inside of the set A. So if we were to check here, cardinality of A intersection B is what? 1, 2. So we have just 2 elements there. So cardinality of that one is 2. So if you also come here, the cardinality of set A here is 1, 2, 3, 4, 5. Because there are just 5 elements inside. So here, the cardinality of B is 1, 2, 3, 4 elements. So there are just 4 elements inside of set B. So that is how you find the cardinality of sets. The next thing we are going to is the complement of sets. Now, what exactly is meant by the complement of set? So, the complement of a set refers to the elements that are present inside of a particular set, that are absent, in a particular set, but are present in the universal set. This is a lot of words, so let us actually know what this means. So example, let's say you have universal sets. Remember, it's noted as this symbol mu. The universal set is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the universal set. Remember I said the universal set is the mother set. This is a set that houses every other set. Every other set are gotten from it. So now this is universal set. So let's say we have a set A to be equal to 2, 4, 6, 8, 10. And you're asked to find A complement or A prime. So this means the complement of A. So A complement. And following this definition, it says the complement of a set refers to the elements that are absent in that particular set but are present in the universal set. That is, what does A not have? Which element does A not have? But those elements are present inside of the universal set. So what A doesn't have but are inside the universal set? What are they? So set A has 2, 4, 6, 8, 10. It has 2, 4, 6, 8, 10. So the elements that are absent inside of set A are the complements of set A. So the elements A doesn't have but are inside of the universal set. So you say your A complement is equal to 1, 3, 5, 7, and 9. So that is the complement of set A. The elements that are not present in that set but are present inside of the universal set. That is the complement of sets. So with all this, you should be able to solve most questions on that set. So now, that is the basics. Let us go into Venn diagrams. So what exactly is a Venn diagram? A Venn diagram is a simple drawing made with circles that helps you show the relationship between sets. So a Venn diagram basically shows relationships between different sets. It's set A, set B, and set C. So it visually shows what elements belong to each set and what elements the set actually shares, which is the intersection of the set, these elements that are common to both sets. And it also shows what elements are outside the set. That means the complements of the set, the elements that do not belong in that set. So now, we are going to work with Venn diagrams now to solve a couple of questions on that set. This is the first one. So example, it says, in a class of 50 students, 30 like maths, 25 like English, and 7 like none of the two subjects. Find the number of students that like both subjects. So now we're going to use Venn diagrams to actually solve this. And what does a Venn diagram look like? So now, here, we're given this question to be in the class of 50 students. So that means the total number of students inside of that class is 50. And if you remember, I said the universal set is the set that houses every other set, the mother set. So here, we can say our total number of students in the class is the universal set of that class. So now, we say in that class, 30 like maths, 25 also like English, and 7 like none of the two subjects. Find the number of students that like both subjects. Now here, we are dealing with just two subjects. So our Venn diagram would look like this. Venn diagram is made with two overlapping circles. For this case, to be two overlapping circles. Overlap means they would enter themselves. So here is how you draw your Venn diagram. We have two circles here because we are dealing with just two subjects. And the subjects are maths and English. If there were 3, we would have 3 overlapping circles. We have a third one here. But for here, we are dealing with just two subjects. So here we have maths and English. So let's call this first circle M for maths, and let's call this E for English. So they said in a class of 50 students. So the universal set, the total number of students in this school is 50. So the universal set is 50. They also said 30 like maths. So our M here is equal to 30. While 25 like English. So E equals 25. And we're also told that 7 like none of the two subjects. They don't like any one of them. They don't like any of the subjects. So 7 would belong outside. 7 is a complement. So 7 will be here. He said 7 like neither of the subjects. And I said, find the number of students that like both subjects. Now, this circle represents the set of students that like math, while this circle represents the set of students that like English. But in that particular class also, we also have students that like both maths and English. And which portion on this Venn diagram represents the part of the students that love maths and also love English? So now the center here represents students that like maths and English. So their intersection here is what we're asked to find. So find the number of students that like both subjects, that like maths and they also like English. So we don't know the value of that one. So let's just call it X. Let us represent it with letter X. And how would we find X? Now, solution. So maths is 30, English is 25, while X is the number of students that like both maths and English, while 7 represents the number of students that do not like maths nor English. So now, how do we find X? So let us do that together now. So we have M equals 30 here, we have M equals 25, we also have X here. So now, this entire circle is 30. This entire circle here is 30. But if you look closely, X has been cut. A portion has been cut out of 30. So for instance, let's say we have a circle here. We have a circle here. And this entire circle is 100. If this portion is cut out of it, let's say they said the value of this portion is 40. What is the value of this portion? If the entire circle here is 100, and we have a portion cut out of it, and the portion here is 40, what is the value of this portion? 60, right? And how did we get 60? Just 100 minus 40, you get your 60. So 100 minus 40 gives 60. So, with that knowledge now, let us do this. This entire circle here, from here to here, is 30. But a portion has been cut out of X. So, what will be the value of this side only? So, the value of this side will be 30 minus X. So, what will be the value of this side? The value of this side will also be 25 minus X. Because X is also cut out of this portion of E. So now, here is 30 minus X, here is 25 minus X, here is 7, and we have our universal set equals to what? 50. But we still haven't solved for X. So let us solve for X. Now, the universal set, remember, is the mother set. That means everybody in the school, the population of everybody in the school is what? 50. So to find the value of X, you have to add this to this to this to this. You have to add everyone in the school together and equate it to what? 50. So let's do that together. So now I have 30 minus X plus 25 minus X plus, don't leave the 7 now, plus 7 equals to 50. Remember, this 7 is also part of the school. There are also students in the school, but they just don't like maths. So let us collect like terms. We have 30 plus 25 plus 7. So I'm collecting the numbers first. I'm collecting the letters. So I'll have minus X plus X and minus X equals 50. So now 30 plus 25 gives 55. 55 plus 7 gives 62. Yes, 62. So negative X plus positive X gives 0. So 0 minus X gives negative X. So this becomes 0. So 0 minus X gives minus X. So we have equals to 50. So let us find X. So my negative X equals 50 minus 62. So my minus X equals to minus 12. So negative cancels out. So my X is equal to 12. So we can say the value of X is equal to 12. So 12 students like both subjects. 12 students like math and also like English. So if 12 students like math and English, so let's say you're further asked, you're told, find, let's say you're told to do something further, you're told to find the number of students that like maths only. So let's say you're further asked to find the number of students that like maths only. So what portion represents people that like maths only? Here. So from here to here is the portion that represents people that like maths only. And what is the equation in it? 30 minus x. So people that like maths only is, so our n into maths only is equal to 30 minus x, and the value of x is 12. So our n into maths only is equal to 30 minus 12. So our n into maths only is equal to 18. So if you're also asked to find the number of students that like English only, so that is just 25 minus 12, so that gives 13. So that is how you work with Venn diagrams. So let us take another question under Venn diagrams. Alright, so we have a question here under Venn diagrams involving 3 sets. So the question reads, a survey of 100 people was conducted to find out which 3 soft drinks they liked: cola, lemonade, or orange. The results obtained were 50 people liked cola, 45 liked lemonade, 40 liked orange, 20 liked cola and lemonade, 18 liked lemonade and orange, while 15 liked cola and orange. It now said 5 did not like any of the 3 drinks. How many people liked all 3 drinks? Now, like I said, a Venn diagram is made using overlapping circles. So here we have 3 things we're considering. We're considering 3 things: cola, lemonade, and orange. So we are going to have 3 overlapping circles. So we're going to have this. So yes, so this is how the Venn diagram would look with our universal set outside of here. So they said in a survey of 100 people, that means the total number of people that were surveyed were 100. So that means the universal set is equal to 100 people. So now, to find out which 3 soft drinks they liked: cola, C, let here be C, cola, lemonade, L, and here be orange, O. So we're now told that some results were obtained. We discovered that 50 out of these people liked cola, so C equals 50. 45 liked lemonade, L equals 45. And 40 liked orange, so O equals 40. They also said 20 liked cola and lemonade, so that is cola intersection lemonade. People that liked cola and also like lemonade are 20. So what portion represents people that liked cola and lemonade? So this is a portion of cola, this portion of lemonade. So here is cola intersection lemonade. So that is 20. That is 20. So it also said 18 liked lemonade and orange. So L and O, 18. 18 liked lemonade and orange. And 15 liked cola and orange. So 15 liked cola and orange. This is intersection. So 15. So we're now asked to find. Okay, said 5 did not like any of the 3 drinks. That means the complement of the set. So 5 did not like any of these 3, so they'll be outside. So 5 did not like, so 5 will be here. So they now said, how many people liked all 3 soft drinks? So this portion represents the intersection of all 3, that is C intersection L intersection O. Let us call that X. Now let us look at this diagram closely. We have labeled our parameters inside. But now we have to do some tweaks. So now, people that liked cola were 50, people that liked lemonade were 45, people that liked orange were 40. So let us find the number of people that liked cola only. Because here is the number of people that liked cola. But we don't know the number of people that liked cola only. So let us find that. So you have your n into cola only is equal to, now how many people liked cola? 50. That is 50 minus, now this portion here, this entire portion from here to here is 20. But a portion has been cut out of this 20. The cut, x was cut out of it. X. So this entire portion is 20, like we're told in the question. But if you look at this diagram well, x was cut out of the portion of 20. So here would be 20 minus x. So also this portion here is 15. Also x was cut out of here. So here will be 15 minus x. So also here 18. So here will be 18 minus x. So this represents the number of people that liked cola and orange only, cola and lemonade only, while this is lemonade and orange only. So now, let us find the number of people that liked cola only. So that will be 50 minus, no, let's take a look at this. So let's say we have a circle here. The value of this entire circle is, let's say it is 100. So let's say a portion of cut out of 100. Let's say the portion here is 20, here is 10, here is 30. So you're not asked to find the value of the remaining portion. Now remember, this entire circle is 100. 20 was cut out of it, 10 was also cut out of it, and 30 was also cut out of it. So what will be the value of this portion here? So that will just be 100 minus, this is 20, that's 20 plus 10 plus 30. So 20 plus 10, 30, 30 plus 30 gives 60. That will be 100 minus 60. So that will be equal to what? 40. So here will be 40. So that's the value of here only. So with this knowledge now, let us solve the question we have on the board. So to find the number of people that liked cola only, that will be just 50 minus, put in a bracket, 15 minus x. So we are going to add this one together, subtract it from this. So that will be 15 minus x plus 20 minus x. So n into c only is equal to 50 minus, collect like terms, we're going to have 15 plus 20 minus x plus x minus x. So we're going to have n into c only is equal to 50 minus, this gives 35. Negative x plus x gives negative, so it gives 0. 0 minus x gives negative x. So I have 50 minus 35, expand the bracket, so we have plus x. So my n into cola only is equal to 15 plus x. So you know people that liked cola only are 15 plus x. So that will be slotted into here. That will be 15 plus x. So we have to find the number of people that liked lemonade only. So that will be my n into L only. So the same thing you did here, you're going to repeat that same step here, but with different values. So people that liked lemonade were 45. So that's 45 minus, the bracket of lemonade is this. So that is 20 minus x plus 18 minus x. That's the bracket, that's the circle of lemonade. So we have 45 minus, correct your like terms, that is 20 plus 18 minus x plus x minus x. So that will be 45 minus 38 minus x. So you're going to have n into L only is equal to 45 minus 38 plus x. So L only is equal to 7 plus x. So the value of this portion is 7 plus x. Now, let us find the value of people that liked orange only. So the next thing to do is to find the expression for people that liked orange only. So the same thing you did in the previous two, you're doing the same thing now. So you're going to have 40, okay, you have your n into orange only is equal to 40 minus, this is the portion of orange. So that's 40 minus, open the bracket, 15 minus x plus 18 minus x. So that will be equal to 40 minus 15, collect like terms, plus 18 minus x. So we're going to have n into orange only is equal to 40 minus 15 plus 18 gives 33. So this will be equal to minus x. So n into O only is equals to 40 minus 33 plus x. So my n into O only equal to 7 plus x. So the value of this portion is 7 plus x. So we have to find, so we have found the number of people that liked Coca-Cola only, people that liked lemonade only, people that liked orange only. So the next thing to do now is, we have all the instrument needed to find the value of x. So let us find the value of x, which is the number of people that liked all the 3 drinks. So what you're going to do now is, we're going to add every single thing in this circle and equate it to 100. So everything I have inside of my rectangle, I'll equate it to 100. So starting from there, starting from here, so I'll have my n into, remember, people that liked all 3 is the intersection of all the 3 drinks. That is C intersection L intersection O. So my C intersection L intersection O is equal to, so you're going to add everything you have inside of here, equal it to what? 100. So you're going to have 15 plus x, 15 plus x plus 20 minus x plus 15 minus x plus 7 minus 7 plus x plus 18 minus x plus 7 plus x plus, remember, don't leave this out, plus 5, people that did not like any of the drinks at all. So plus 5 is equal to 100. So you have to collect your like terms here. So we'll have 15 plus, collect the numbers, 20 plus 15 plus 7 plus 18 plus 7 plus 5. So the x is 2, so we'll have plus x minus x plus x minus x plus x minus x plus x equal to 100. Do I have everything correctly? So we have 1, 2, 3, 4, 5, 6, 7 x's. So we have 1, 2, 3, 4, 5, 6, okay, 7 x's. So let us find the sum of all this. So let me get my calculator. So let us find the sum of all this and get our answer. So 15 plus 20 plus 15 again, plus 7, plus 7, plus 18, plus 7, plus 5 equals 87. So equals 87. And we have x minus x gives 0. So x minus x also gives 0. So x minus x also gives 0. So we are left with just one x. So all this equals to 0. So we have x. So we have 87 plus x equals to 100. So my x is equal to 100 minus 87. So my x is equal to, that will give 13. So the value of x is equal to 13. So that means the number of people that liked all 3 drinks is equal to what? 13. That is the value of x on these Venn diagrams. So guys, with this knowledge you can solve any question under sets and Venn diagrams. So I hope you were able to follow through with the examples I've been doing, and if you have any questions, leave them down in the comment section. Remember, nothing is hard if you put your mind to it. See you next time, guys. Take care.